Okay, all right. So welcome everybody to the fifth seminar in our series, Modern Methods in Social Policy and Intervention Research. Today, I'm very pleased to say that we've got Dr. Eva Thomann talking about qualitative comparative analysis, principles and application. So Eva is a political scientist, who specializes in public policy and public administration. She works as a full professor of public administration at the Department of Politics and Public Administration at the University of Konstanz and serves as the co-editor of the journal Regulation and Governance. Eva's research interests include Europeanization and European integration, street-level bureaucracy, multi-level governance and problem solving, social equity and bureaucratic discrimination, private and hybrid governance, and behavioural public policy and administration. Empirically, she's particularly worked on public health policy, food safety policy, immigrant and welfare policy. And from a methods point of view, Eva works with case-oriented and set-theoretic research methods and serves in, among other places, the Comparative Methods for Systematic Cross-Case Analysis network known as COMPASS, which is what she's going to talk to us about today. So I'd like you all please to welcome Dr. Eva Thomann. Eva, I'm going to give the virtual floor to you.
Thank you so much, Mark, for having me, and a warm welcome to everyone. I'm just going to share my screen. Can you see that?
Yes, I can. Yeah, that looks great. Yeah, great.
So, whenever I'm asked to talk about QCA, my biggest fear is that it's going to be basically like most of the methods training I've received as a student, mainly quite boring. And this is definitely not my goal today. So given that we are here at the Department of Social Policy and Interventions, my presentation is going to be partly based on some of my recent work, including a chapter about the use of QCA for comparative policy analysis, as well as actually our forthcoming book about QCA using R that I'm co-authoring with Nena Oana and Carsten Schneider, which will be published with Cambridge University Press. And I just had the pleasure of checking the last proofs yesterday and sent them out. And so some of what you see today is basically hot off the press. So today I would like to broadly talk about the question, what QCA has and does not have to offer for social policy analysis. And to this end, I will talk about, in the beginning, about what QCA is and just a basic overview of how it works. And I'm going to explain that using an example of an applied published a QCA study. And this will lead me to a more general explanation of what kinds of research questions that we can use QCA for and what kinds of research question we cannot use it for. I will then give you a very brief overview of the state of applied QCA over time and also the application of good practices in applied QCA. And I will then conclude with just some strengths and weaknesses of QCA for comparative policy analysis. Now, in doing all this, I just want to emphasize that I do not think of QCA and will not present QCA as an inherently useful or good method. You know, like any empirical research method, QCA is a tool which is good for some purposes and not for others. And so my goal today is to give you an overview of what kind of tool QCA is and what we could use it for. So what is QCA? In fact, it is quite a young method. It was developed by Charles Ragin, a sociologist in the 1980s. And Ragin was very successful in publishing, but also dissatisfied with the existing toolbox of empirical research methods that he had at hand. He criticized quantitative and also experimental techniques for making what he would call like an unrealistic assumption of looking at the isolated effects of single variables holding everything else constant. And so what he would say is that it does not really make sense to make this assumption, because in reality, the phenomena that we study consist of specific combinations of many factors, and we need to understand how they work together. At the same time, he was also dissatisfied with the state of qualitative methods, which would very much focus on single case studies, where he said it is good to get an in-depth understanding of cases, but we also need, in order to learn and to generalize, we need to compare cases and we need to find regularities. And so QCA is an attempt to kind of combine the best of both worlds and combine qualitative within-case analysis with a formalized cross-case comparison using dataset observations. Now, QCA has some basic features. It is a set-theoretic method, which means that we look at social reality as the phenomena sets where cases have membership in or not, and then we look at relationships between these sets. And I will illustrate in a minute how that looks like. It is a configurational method, so it assumes causal complexity, and specifically 3 aspects of that, which I will also show you later what it means. And it is used to identify necessary conditions and sufficient conditions for an outcome. So it does not serve to identify correlations or mean effects of variables on some dependent variable, but it looks at necessary and sufficient conditions. So I will spend the next couple of minutes just walking you through these different elements. But before I do that, I would just like to illustrate the basic logic that we use when we use QCA using an example. And the purpose of the example is just to show you that depending on the analytic approach that we use, we could actually reach quite different results. Now, the example is, it's already a long time ago. It was the US elections in 2000 when George Bush ran against Al Gore. I still remember that. And a lot of weird things happened during these elections. And one of them was that actually in Florida, the media already declared Al Gore as a winner before the last polls had closed in the Panhandle counties that are in a different time zone. And there was some research about how that might have actually affected the election's results. And there was a study by Lott who used a difference in difference regression to say that basically he calculated that Bush probably lost about 10,000 votes. I'm not going to go into the details of how they reached these numbers, but it's just to illustrate the differences in approaches. Now, Brady in 2010 used quite a different approach, way of arguing, to say that, well, probably Bush only lost between 28 to 224 votes. So how could they reach to these, get to these very different numbers? Now, let me show you the basic argument Brady made. And he didn't actually use QCA, but it's the kind of argument we make with QCA. He said, well, in order for someone to count, to be a lost Bush voter, first of all, this individual would have to be a potential Bush voter. So there are a lot of people who would never vote for Bush, not even in their wildest dreams. And so only if somebody is a potential Bush voter in Florida, then they also need to actually have registered as a voter in one of those Panhandle counties. And we know that registering for a vote in the US can be quite a hurdle. They also had to have actually consumed the news quite late in the day when the media declared Al Gore as a winner. Otherwise, they would not have noticed that. And also, at that point in time, they needed to not actually have voted yet. And so only if an individual is a member of all these different sets of people, are they potentially a lost Bush voter. So they need to display all these 4 characteristics together. So this is a set-theoretic argument because we look at different sets, for example, the set of potential Bush voters in Florida, and then we determine whether a case, here an individual, is a member of that set or not. It is a configurational approach because we're not interested in the effect of one factor, but we want to understand how these different factors work together. And only if they combine do they have a causal role. And finally, this is an argument about necessity. So it is necessary for an individual to be a member of all these sets here in order for them to be eligible as a potential Bush voter. But it is not yet sufficient for that. And so this is the kind of argument that we make with QCA. When using QCA, the method is based on 3 logical operations, Boolean operations. And we use these operations to combine different sets. The first one is the logical and. So let us assume that we are looking at students and we are interested in identifying good students, okay? So let's say we have 2 sets. On the one hand, the set of students that have good marks, whatever that means. And then we have the set of students who participate a lot in class. And we could say, okay, we want to get the set of excellent students that are those that both have good marks and participate in class. So the set of good students, excellent students, is the set of students that are members in both sets. And that's basically the area here where these 2 sets intersect. So this is the logical and we use this multiplication sign to denote the logical and. And so we would call this a set intersection or a conjunction of different sets. The second operator is the logical or. So let's say we are interested in the set of students that are talented, and we can say, well, these are the students that either have a good mark or participate in class. I don't know why my PowerPoint somehow wants to continue with the presentation. So we would say the student either has to be a member of this set of students with a good mark, or he has to be a member of the set of students that participate in class. And the logical or denotes the full area, so the full set of students, either a member in this set or in that set. And we use this plus sign to denote the logical or. And we would also call that this union of 2 sets or more sets, and or a disjunction. And the final operator is the logical not. So basically, if we have the set of all students and we have a set of talented students, then all the students that are not in this set of talented students are the not talented students, which doesn't necessarily mean that they are bad students. It just means that they are not talented, the way we defined it. And we use this tilde sign to denote the negation of the set. And so basically, with QCA, we look at causal complexity using these different operators and looking at complex combinations of sets and their negation. So let me walk you through the different steps of a QCA analysis. And I will do that based on an empirical study by Tina Freyburg and Lisa Garbe, where they analyzed the question why even Africa's most stable democracies sometimes intentionally shut down the internet access for the public during elections. And they focus on elections in Sub-Saharan African countries between 2014 and 2016. And so that's a set of 33, both presidential and parliamentary elections. And so with QCA, we would call the phenomenon that we want to explain the outcome. We don't say dependent variable because it doesn't depend on anything. And so their outcome is the occurrence of internet shutdowns during elections. And they then look at 3 different explanatory factors. We call them conditions in QCA. And the first one is the question whether the internet service provider is owned by the state or is in private hands. So the question also, how much control does the state actually have over the provision of internet services? The second condition is whether the government is an autocracy or not. And the third condition is whether there was an occurrence of electoral violence during these elections or in the weeks prior to the election. So the example I'm showing you is using crisp sets. So all of these, the conditions and also the outcome take on the value 0 or 1, they're either absent or present with no degrees in between. With QCA, we can also analyze degrees of set membership. So there would be also values in between 0 and 1, but this is not an example of that. This is a crisp set QCA, not a fuzzy set QCA. All right, so what we then do with QCA is that we analyze necessary or sufficient conditions, and we look at them as relations between sets. So let me just illustrate this. This is not yet a finding of that study. It's just a hypothetical example. So we could say, let's say that ISP state ownership is a necessary condition for internet shutdowns to occur. So what that means is that for internet shutdowns to occur, the state has to own the internet service provider. And empirically, what we would see is that all cases so all elections where we saw an internet shutdown are also cases where the state owned the internet service provider. There's no case of internet shutdown that is not also a member of the set of ISP state ownership. And so what that means is that the condition set is fully inside of the outcome set. It's a subset of the outcome. And so it's a subset relation between the condition and the outcome. Sorry, it's the other way around. The condition is a superset of the outcome. Stupid mistake. The condition is a superset of the outcome. So the all cases of the outcome are also a case of the condition. And so we can denote this like this. X is a superset of Y or equals Y. And what we use here is a backward arrow to denote necessity. So that's necessary condition. And sufficient condition are different. For sufficient conditions, the condition is a subset of the outcome. So for example, we could say, whenever the state owns the internet service provider, we will see internet shutdowns. So basically, empirically, all cases where the state owns the internet service provider would also be a case of internet shutdown. So these cases, the condition is a subset of the outcome set. And this is how we can denote it, and we can use a forward arrow. X implies Y to denote sufficiency. But there could also be other reasons for internet shutdowns to occur. So the cases here that are cases of internet shutdown, but not cases of ISP state ownership, there might be a different explanation. So it's a subset relation where the condition is a subset of the outcome. Now, when we use QCA, typically we're not interested in subset relations between simple sets like this, but we would look at subset relations between complex combinations of sets and their negations. Now, how does that work? There are different steps of a QCA analysis. Not all of them are actually unique to QCA. So the ones that you see shaded gray here, they are just steps that are involved in any empirical research. And we distinguish 3 phases. So there is the phase before the analytic moment where we design our research, conceptualize it, embed it in theory, and there is then a specific step for QCA or anyway for set-theoretic methods, which is when we transform the scores of the cases into set memberships. And that step is called calibration, set calibration. So for example, let's say for the set electoral violence, we are probably measuring this looking at the occurrence of protests in the streets, maybe also the question whether the police was involved or not, right? And then we need to decide how many protests and which level of police involvement does a case need to have in order for it to be a member of the set electoral violence. So we need to define qualitative thresholds for cases to be attributed as members or non-members of the set. And that step is called set calibration. Now, the phase of QCA as a technique relates to the actual analysis of necessity and sufficiency. It's based on a highly formalized comparison of the scores of cases in the different sets using a specific algorithm called logical minimization algorithm. And so we will determine whether, based on a cross-case comparison, whether certain conditions are supersets or subsets of the outcome. And then the phase after the analytic moment refers to, on the one hand, a variety of different diagnostics and robustness tests. And we will then also engage in the interpretation of the results and relate them back to cases and to our theory. So in what follows, I will illustrate the technical moment, the analytic moment of QCA. Okay, so I will focus on the analysis of sufficiency. The authors did not find necessary conditions for internet shutdowns. But for analyzing sufficiency, we construct a so-called truth table. So this is a truth table. What we have in a truth table is it displays all logically possible combinations of conditions. So in this analysis, we have 3 conditions. So we have 2 to the power of 3. That's 8 possible, logically possible combinations of the occurrence and non-occurrence of these conditions, which we have here. And then on the right-hand side, we can see that we can attribute each case to a row. So each case displays a specific combination of conditions. And so far, we just have a descriptive tool. So the truth table is a nice way of summarizing the data and seeing the different combinations that we see. In this analysis, nicely enough, each possible combination is actually observed empirically. But sometimes it happens that not all of them are observed. So we might have some rows that do not have cases in them. They are called the logical remainders. Anyway, this is not a problem here. And now that we have attributed the cases, the next step is to determine whether some of these combinations here are sufficient for the outcome. And so to recall, they would be sufficient if in all of these cases, this combination would actually result in internet shutdown. So here we are explaining the occurrence of internet shutdown. So we can check that for each of these cases, right? Whether they resulted in internet shutdown or not. And the consistency value actually tells us the consistency with which the cases display a subset relationship. So if it has a value of 1, we have a perfect subset relationship, and these rows are perfectly sufficient for the outcome. So all these cases here in these first 4 rows are sufficient for internet shutdown, all these configurations. And we see down here, these are rows which are not sufficient for the outcome internet shutdown. So not all of these cases here display internet shutdowns. So that's brilliant. Now we have, actually here we have all the combinations of conditions that are sufficient for internet shutdown. But now we want to simplify this. This is a very complex depiction of these sufficient conditions, and we want to see whether we can get to an easier way of presenting this. And the way that we get there is through the process of logical minimization. So we have, based on a consistency score, we can assign an output value to each row. The output value tells us whether the row is sufficient or not. If it's 1, it's sufficient. If it's 0, it's not sufficient. And the logical minimization is based on those rows that are sufficient. So here on those 4 rows up here. And the way this works is that we perform pairwise comparisons of the truth table rows. For example, we can see that these first two rows are identical. So both there are cases of not state-owned internet service provider and electoral violence. They only differ in this condition autocracy, which is once present and once absent. And so what we can say that here in these cases, it does not matter whether autocracy is present or absent. Both of these scenarios lead to internet shutdown. So we can minimize away autocracy. It is redundant. And from this complex expression, not ISP and violence and autocracy, or not ISP and violence and not autocracy is sufficient for shutdown, we get to a much simpler one, which is simply not ISP and violence is sufficient for shutdown. So that's how logical minimization works. And we do that for all the different truth table rows that are sufficient. So if we compare these two rows here with each other, for instance, we see that they are also identical, except that electoral violence is once present and once absent. So we can also minimize that away. And this is how we then get to the results. And so we find that there are two combinations of conditions that are sufficient for internet shutdown. First, either the internet service provider is public and the government is an autocracy. So basically, autocracies will shut down the internet if they own it, or the internet service provider is private and there is violence. So maybe these private internet service providers have decided that they don't want to contribute to further violence and have to the spread of whatever, incitements for violence and so on. And so they have decided to shut down the internet. And so this is the result of the cross-case comparison. And we will then use case studies for each typical cases for each of these combinations to actually illustrate the interplay of these factors and how they lead to internet shutdowns. So this is where the cases come back in, and this is then the qualitative element of QCA. We also get results for, we also get sufficient conditions for the internet not being shut down. And what the authors find is that either the internet service provider, is that correct? Oh yeah, the internet service provider is public and the government is not an autocracy, or the internet service provider is private and there is no electoral violence. So these are the two combinations in which the internet is not shut down. So earlier I've talked about the different elements of causal complexity, and we can see them all here in these results. The first element is configurational causality. So what we see here is that it is specific combinations of conditions that work together in leading to the outcome. It's not a single condition. State ownership on its own is not sufficient for shutdown. It depends on whether it combines with autocracy or not autocracy. It will result in a different outcome. The second assumption is equifinality. So basically, more than one path might actually lead to Rome. So what we find here is that we have two mutually non-exclusive pathways for internet shutdown, or sometimes they're called recipes or configurations that lead to internet shutdown. So we are not calculating one model that fits the whole data, but we are looking at different substitutable pathways for an outcome. Some of them might display many cases, and some of them might display very few cases or only one case. And the third element of causal complexity is causal asymmetry. So we can see that the results for not the internet shutdown are not just a mirror image of the results for shutdown. And so we will separately analyze the negated outcome and the necessary and sufficient conditions for the negated outcome in order to understand what causes, the negated outcome. I mean, for example, just because not having enough money might make you unhappy, but from that, it doesn't necessarily follow that having enough money makes you happy. So if we want to understand what makes you happy, we need to analyze that separately. We can't just infer that the presence of enough money is enough. So from this now we can see that QCA results tend to be complex. They reflect the complexity of that is displayed in the cases. And they are often a lot more complex than the ones from this analysis. This one is actually nicely simple. And so a big challenge for QCA studies is certainly to meaningfully interpret these results and understand how these factors in these configurations actually work together. And this is where it is very useful to rely on case studies. And actually there is a whole tool set, it's called set-theoretic multi-method research, that a whole toolbox of case selection principles for picking the relevant typical and deviant cases to understand these results and also to match them for targeted pairwise comparisons. And so set-theoretic multi-method research can be used, for example, to analyze the causal mechanisms and to understand what are the necessary elements of the causal configurations and which ones are not necessary. It can be used to identify scope conditions for the results. It can also be used, for example, when analyzing deviant cases that we couldn't explain or that contradict the results. We can understand additional overlooked explanations and so on. So in this study, Freyburg and Garbe, they perform additional case studies of Congo and Uganda to shed more light on the underlying mechanisms. Whether we analyze necessary conditions or sufficient conditions, there is basically the same protocol for doing that, which consists of 3 main steps. In a first step, we want to determine whether there is an empirically consistent set relation, either of necessity or sufficiency, and we will do that first based on the parameter of fit, consistency. And we will then also check whether there are deviant cases that basically contradict or falsify a set relation. And if there are some of these, we're going to analyze them to understand what the reason is and whether it can help us actually improve our, for example, our calibration of sets, or whether we have overlooked an important factor, and so on. The second step is to determine if we find an empirically consistent subset relation, is to determine the empirical importance of this relation. And here we will rely mainly on the coverage measure, which is the second parameter of fit that we use, which basically tells us how much of the variation of the outcome or how much of the cases that we could actually explain with our condition or our conditions. And then the final, so if we have an empirically consistent and empirically important subset relation, we will also look at the question of substantive importance. So we will see whether we can meaningfully interpret the set relation in light of existing, external knowledge, existing theory, our concepts, our knowledge of cases. And so just like correlation does not equal causation, set relation also certainly does not equal causation. And so we need to be able to get to a plausible and meaningful explanation for the results. Okay, so having explained the basic logic of QCA, let us now take a step back and think about, so what could we use this method for in public policy research? Now, in general terms, QCA is well suited if the researcher has an interest in, like if you depart from kind of a phenomenon or a puzzle and want to understand why that occurs. So we would call that the effect of causes types of research questions. So we depart from an outcome and then want to get a comprehensive explanation for that outcome. It is not well suited to give you the specific effects of a given cause on the outcome. So we don't have effect sizes, we don't have the results for single variables, we only get combinations of variables and whether they are necessary or sufficient. So there are no degrees of effects here. Well, at the agenda setting stage, for example, QCA might help us to understand why problem definitions and perceptions change, why they vary, why, for example, certain problems make it on the agenda and others don't. Or we could use QCA to analyze how and why policy decisions come about, why some options are preferred over others, and how and why policy outputs vary and change also, perhaps over time. QCA is often used in policy implementation research, including that's my area of specialization. So for example, we could use QCA to understand why certain policies succeed and why others fail, how we can explain variation in policy implementation. And it is very well suited to analyze interaction of different factors in policy implementation. And when it comes to evaluation, which I guess many of you are interested in, we can, for example, use QCA to identify specific combinations of interventions which work in specific contexts or not in others. So the assumption of equifinality allows us to identify configurations of context with mechanisms. So generally speaking, we can use QCA when we assume or expect some element of causal complexity. For instance, that several factors work together, or that there might be more than one pathway toward an outcome, or that maybe the occurrence of the outcome has a very different explanation from its non-occurrence. And we need to be able to explain this outcome, or we need to be interested in necessary or sufficient conditions for the outcome. If we are not interested in that, if we're interested in effect sizes, there is absolutely no point in using QCA. All right. So how widespread is QCA really? And where is it being used? On the left-hand side, we can see that the use of QCA has definitely increased over time. And that is also because there has been more and more methods training in QCA, for example, at method schools, such as the ECPR method school. And also because several prominent textbooks were published by Charles Ragin, Benoit Rioux, Claudius Wagemann and Carsten Schneider. And more recently, there have been a couple of very nice textbooks coming out. But we still can't really say that QCA is that it is a mainstream method. So the peak that we have here is about 100 applications in, I think, 2050. So it is still a bit of a niche method, and there can be quite some confusion over the appropriateness of QCA for analyzing different questions. There are also critiques coming at QCA from different corners. So the method is still developing, and there have been amazing methodological innovations and progress in the last couple of years, specifically. For example, set-theoretic multi-method research tools for evaluating theories with QCA, for testing robustness, and especially the implementation in the software, for example, in R, has really made a lot of progress and become a lot more user-friendly over the last couple of years. So we can see that QCA is especially popular in the fields of business and management research, and also in political science, particularly also in public policy research, and also, for example, in policy evaluation research, it's used quite often, and also in other fields mainly of the social sciences. what you see here is the results, or some results from a systematic review of QCA applications in the field of public administration that I have performed with Jörn Ege and Ekaterine Pastian. And what we measured here, amongst other things, is the extent to which the empirical studies adhere to the good practices that have been proposed by methodologists. What we see here on the upper left side is that overall, generally speaking, the adherence to good practices has really improved over time. However, it is still imperfect. And so there is still a need to improve the use of QCA in practice. We then looked at the implementation of good practices separated for the 3 different stages of analysis. So before the technical moment, during the technical moment, and after the technical moment. And we see that the use of good practices during the technical moment has really improved over time. And again, that is certainly also because of the rigorous and high quality methods teaching, because of the different textbooks that are out there, and specifically also because of the progress that has been made in software application, which enables users to implement good practices quite easily. However, we see that especially before the analysis, there is still, there is still scope for improvement. And so basically what this means is that applied QCA often tends to make, for example, analytically incoherent choices when designing the research. And also when conceptualizing, for example, when conceptualizing the sets and calibrating them. So there is a need to put increased emphasis on the teaching also how to design QCA research in a methodologically sound manner. And some of the criticism voiced toward the QCA method is actually based on shortcomings in applied QCA. And so what we can see here is that there is, in fact, scope for improving that. And what we argue is that what we need is, on the one hand, teaching more also of research design choices, but also it has to be a joint efforts also on the behalf of on users and on the behalf of peer reviewers reviewing QCA articles to put more emphasis on a stringent application of good practices in applied research. And also maybe the good practices themselves require evaluation and development. Okay, so to almost conclude, what are some strengths and limitations of the QCA technique? QCA is well suited to apply causes of effects types of research questions. So if you depart from a puzzle and want to explain the puzzle, that is a good use for QCA. Or for example, you have a variation in policy results and you want to understand the reason for this variation. It is a good method to identify necessary or sufficient conditions for an outcome. And specifically, it is, I would say, the most advanced method, or one of the most advanced methods to do that while accounting for causally complex patterns. So configurational patterns, equifinal patterns, and asymmetric patterns. And it is a nice method if you are interested in kind of combining a systematic comparison of cases with a targeted analysis of within case analysis. What QCA alone can't do is to, on the one hand, it's a cross-sectional method as such, the technique, so it can't really account for temporal dynamics. QCA on itself can't trace changes or processes over time. It also can't unravel causal mechanisms or narratives. So if that is the goal, then QCA should be combined with other techniques, such as, for example, process tracing, or there is also now an implementation in R for panel data QCA and, generally speaking, cluster data QCA in order to, so you can perform the analysis at different points in time and then look at how stable the results are. QCA is not a good method to give you the specific effect of a single intervention. Everything else held constant. QCA doesn't do that. It doesn't give you that. So if you're interested in average effect sizes of single variables, then other methods are better suited. And that is because, also crucially because of this assumption of equifinality, which means that we're not calculating the one model that best fits the data, but we are allowing for several different models, alternative models. And partly as a consequence of that, QCA results tend not to be very stable. They tend not to be very robust. So as we add or remove cases from a sample, or also change analytic decisions, for example, relating to calibration, we would see sometimes quite significant changes in the results. So if we think back to the truth table, if you remove or add a case, you might add or remove a new configuration, a new row to the table. And even if it's just one case, if it's a new configuration, it will be considered during logical minimization. And we want that. So QCA is meant to be a case-sensitive method. The goal is to learn from cases, also from rare cases, because we are interested in cases as complex wholes, as configurations, and we want to understand what these configurations can teach us. What can QCA then offer to policy analysis? Well, it is a set-theoretic, it is a case-sensitive and a truth table-based method. And it accounts for causal complexity, but it has also limitations in accounting for temporal dynamics, and it doesn't give you isolated mean effect sizes. And importantly, QCA is not at all just regression written small. So one of the most frequent mistakes that I get from beginners is, oh, I don't have enough cases for a regression. Can I do a QCA? So it is true that you could use QCA already, to compare, like, say, 10 cases. But you can also compare thousands of cases with QCA. But QCA does not give you correlations. It does not give you effect sizes. It gives you necessary and sufficient conditions. So that's something very different. And you could use QCA and regression on the same data set and get completely different results because we are looking for different empirical patterns. Also, QCA is a very flexible method in the sense that we can use it in more theory evaluating or more exploratory ways. And you can also use QCA, with a strong integration of case studies and a strong qualitative focus, or you could use it in a less case-oriented way, just to compare, to perform cross-case comparisons. And there are also different ways of, so you can actually derive different types of solutions with QCA, some depending on whether the researcher wants to emphasize the parsimony of the result or the complexity of the results. What is really important when using QCA is to adopt a coherent analytic approach. So to match, so to think about the goals of the research, theory testing or not, and so on. And then match the tools that are chosen with these analytic goals, because otherwise what we see is this insufficient adherence to good practices in applied research. Okay, so I hope I have been able to spark some interest in QCA among some of you. And if that is the case, I warmly invite you to get more involved. Mark has mentioned the Compass network in the beginning, and feel free, or also feel very welcome to check out our website. We also organize events and trainings and so on. And if that's too much for you, there's also just a Facebook group which you can join with one click. It's called Qualitative Comparative Analysis in Fuzzy Sets. And users regularly ask questions there, and all the different QCA experts who are on Facebook answer the questions. So it's a really nice group. That's all. Thank you very much for your attention.